difficulties and problem, you can ask the questions in the chat box. It's for the participants, or at the end of the presentation, you can directly ask Ms. Reem.
Okay.
Please share the slide and start the session, Ms. Amal.
Okay. Can you see my slides?
Yes.
Okay. Well, thank you everyone for coming in. Today I will be presenting to you an overview of my experience with automatic speech recognition applied to the case of firefighter emergency calls. So let's start with my contents. I will first start by introducing myself and my background. Then we will move on to the establishment in which I conduct my work. And later we will see the project on which we're working, which is an AI assistant for emergency call processing. Now for me, my name is Reem. I did a bachelor's degree in computer science at the University of Avignon. I did my master's. I am just now finishing it in artificial intelligence at the university. I had 2 internships that were in the lab as well, and that were revolving around data processing and data collection for NLP tasks, as well as some data analysis tasks. And right now I am doing an apprenticeship I'm in an apprenticeship contract that is 2-year long, that includes work with speech processing and language. My parent establishment is the ELIA. It is the Laboratory of Computer Science of the city of Avignon. It is attached to the University of Avignon. And in the lab, we work on 3 main fields of study. We have people working in networks, people working in the field of optimization, operations research, and applied mathematics. And then my team that works on automatic speech recognition and natural language processing. And similar tasks, of course. Now, I'm gonna present to you the project on which I was assigned these past 2 years. We are collaborating with the SDIS 31, SDIS 31, and I will be presenting you this establishment. Now, the SDIS 31 is the firefighters department for a region in France that's called La Haute-Garonne. 31 is the department number. We collaborated with this firefighters department to be able to see together how we can implement AI to their benefit, to the benefit of their everyday function. Now, to quickly present the SDIS, as you can see, they have around 2,000, a bit over 2,000 firefighters working there. They're working on the clock every day, 24/7. As for their statistics, they have 30% women, and 65 of the firefighters are actually volunteers. They get there, they do a course and a bunch of classes, and they can get to practice voluntarily. A bunch of numbers. So The CTA. The CTA is the service in the firefighters department that takes the emergency calls. So this service takes around 1,000 calls a day. Around 300,000 were counted per year. And every call processing agent takes almost 10 hours of calls a day, 10 hours of like practices for 10 hours a day. So it's almost 10 hours of taking calls back to back. Now, the project we're working on aims to apply AI for speech and text to the benefit of the operators taking emergency calls to help them extract information more intelligently and in a more optimized manner from the emergency calls in real time. So our vision is a tool that is backed by AI technologies, by state-of-the-art technology that is adapted to the context in which we are, and that can offer assistance during the call processing. So first, we had to create a proof of concept to illustrate what our tool would look like. And we decided on a group of functionalities that we wanted to implement. So first, we have verification. We need to verify the caller's personal data as they say it during the call, as there can be errors, whether pertaining to spelling or bias during the call processing. So the AI is supposed to help with that through speech recognition. To alert, we need to alert the agent if they are making mistakes, and that again through speech recognition and as well as some text technologies like named entity recognition, where we recognize a word that may be important grammatically, and that we can grab the agent's attention to. Our tool is supposed to assist during the call in real time in order to optimize workload, in order to get them the pauses they need. So to get the agent to take a break when his focus or her focus isn't serving them. We need to identify what emergency type, and in this part of our functionalities, we want to take the text extracted from the audio call. So we want to transcribe the call, and from the transcription, from the text that we were able to extract, decide which words are the most prevalent and the most important to the emergency, as for instance, the emergency type, and observations that are surrounding the emergency. We want to eliminate errors and human biases. One of the human biases that we come across, and that was the trigger for the start of this project, was confirmation bias. Was when let's say I hear a word, but I'm thinking of another concept. I could attribute the same that word to what I understood, even when it is not true. And unfortunately, humans aren't perfect, and it may happen. So the AI assistant is supposed to give an unbiased, hopefully, and a precise aid in order to avoid these biases. And finally, we want to suggest. Not only do we want this AI tool to prevent errors as much as possible, we also wanted to suggest whatever information, again, by the biases that we have, some information that may be forgotten or neglected during the processing. Now, I know that was a mouthful. That was a lot of functionalities. We were very ambitious with this project, and we still are. Now, I will be talking about ASR and the way we want to be implementing this tool. So first, we receive the call, we receive the audio. So either we receive the whole audio recording of the call in cases of, let's say, learning on data and dealing with past data. But ideally, we want to do this in real time. So we would be getting segments, small segments of audio recording each time. We take that recording, we put it through speaker diarization. Now, speaker diarization is the separation of speakers during a dialogue that has two or many speakers in it. And the goal is to know who says what during that time. So after we extracted the diarization, we know who said what and at what time. We apply ASR systems to transcribe every bit of that conversation. After that, after we're done with the transcription, we want to take that text and apply intent detection and named entity recognition and concept detection on it in order to extract information that would be important to the emergency. So that is a very that is a context-aware task that should take in context the call and the case of an emergency. So the goal eventually is to get to create a model that that can do that. Let's start with call recordings. As I said, we're taking a call that is an emergency call. It is a private information, and it should be supervised by legal by jurists from our establishments or from outside. So we must follow the GDPR. If you don't know what GDPR is, it is a text of law that supervises and monitors data usage and data protection throughout Europe, and respecting as well the AI Act, which came out quite recently and which monitors the use of data, but also the use of AI and their limitations. Now, we must respect this area, and we may have to perhaps give up on some functionalities as the data we are dealing with is very, very risky. Now, speaker diarization. As I said before, we take the data, we segment it, we know who said what. Now, in order to do that, we want to encode the audio recording. We want to turn the audio, the WAV file or the MP3 file into a bunch of numeric values. We want to take that, segment it into small bits, and those small bits are going to be clustered, put in clusters, so we can classify them according to the different speakers. In my experimentation, I used the tool called PyAnote. It is the most popular one so far for speaker diarization. The results on paper are quite good for PyAnote. However, since my data quality wasn't on top, since we have problems with noise, with noisy calls, with bad quality, with audio recording compression that may remove some of the information, the quality of the diarization was not perfect. Sometimes we do not detect speech, sometimes we do, sometimes speakers are confused, and that is a very normal thing with noisy data, and it hinders significantly audio segmentation. Now we have ASR. We finished the segmentation. We know who said what. And now we want to take every bit of speech and transcribe it to text. Now, one of the tools that I know and that is state of the art right now is Whisper. Whisper system. Now, Whisper is a model that is multilingual, that was fitted and trained on multilingual data, and I use a version that is fine-tuned on French data, so we can be a bit more language aware. And we want to take that and transcribe our audio with. Now, keep in mind, I only have a small amount of audio that is restricted in usage. So we always have to bear in mind that constraint when conducting the experiments and when evaluating our results, which may not be so good since this is a real life situation. Information extraction. We have the text and we want to know what information I should take into account. So for instance, let's say the type of emergency. Is it a fire? Is it somebody having an illness? So this model that we will be working on, this system we want to work on, should be able to take into account the context, that is emergency, and be able to decide whether or not a word is worth keeping or not, and whether or not it is worth bringing forward to the call agent while they are treating the call. Now, with that being said, I would like to wrap this up. I want to introduce you to my my team. My two supervisors are Ms. Corinne Fredouille, who is a full professor at Avignon University, and Jean-François Bonastre, who is as well, and he also works they both work in research labs. Ms. Corinne is at the ELIA, and Mr. Jean-François Bonastre is at the INRIA, which is a lab that tackles more of the security issues when it comes to AI. So the team was pretty cohesive, since Ms. Corinne Fredouille worked on data that was noisy, that was not very clean, and Mr. Jean-François Bonastre came with his experience in forensics and in risky data. So there was a good cohesion. Now, I'd like to thank you for listening. Here are some resources that I would love for you to check out. So we have the Whisper model that was created by OpenAI. We have Bionote. We have the GDPR. It is always important to take a look at that and to know where we are in regulations, and the final draft of the AI Act. Thank you so much for listening. I will now drop my slideshow.
Yeah, thank you very much, Ms. Reem Amaret. It was super. Just if there is any question from the participants, we would like to have it. Any question, please? Someone is just joining right now, so I face some difficulties in the challenges with ASR, like for signal analysis, for feature extraction, or some phonetic with alphabet with different languages. Like in Persian, we have different type of alphabets. In French, there are some other, or in English as well. So is there any specific algorithm that support, for example, Persian, Arabic phonetics for
Mm.
text summarization or speech classification, if there is any idea related to this.
From what I've seen personally, I've seen Arabic transcription tasks that used a romanized version. I don't know if that's good enough for you, but basically they transcribe the in Arabic, but they write it in like Latin letters. This way, it is encodable, or you could just encode Farsi, but I'm not sure how feasible that is now. Farsi, I think, is one of the languages that is not very used in NLP experiments,
Mm. We
right?
we are the first that we worked with Persian Dari,
Oh, Persian, sorry.
and the text classification of Pashto. We used like bird or distal bird stuff, which are
Yeah.
okay, but still we are facing some difficulties. For example, implementing or data cleaning or feature extraction, or some difficulties with the signal analysis or denoising. These are the
Mhm.
main challenges and problems that we have with
Yeah.
Persian, uh, uh, with Persian language. So we worked on that, but still, when we are trying to run the course, we are facing that there are low accuracy. I mean, for low resource language, we have some difficulties. If you have any idea or something new, please share with us. We will be happy.
Oh, honestly, I wouldn't be able to help anymore. Even French, even though it is pretty used, we're struggling a lot with the audio quality. I think it also depends on your data. How much data do you have? And how is it annotated? Like it's annotated in Persian letters?
Yeah, yeah, it was in Persian letters. So, by the way, if there is any other question from the participants regarding the tools or the things related to speech and the topic that presented here, please let us know.
There's a question from Munib Ahmed.
Mhm.
I have a question. Is there any difference between ASR and STT? And do I have used ASR instead of STT? I'm sorry, what is STT?
I think STT is the transformation form of ASR, which is using with deep learning. Um, I
Oh, single, I'm sorry. Oh, STT is speech to text? Oh, okay. Well, I think we are on the same page here. When I speak of automatic speech recognition, I speak of speech to text as well, uh, because Whisper is based on a DNN, based on a deep neural network, and encoders. So I think yes, we are on the same page. Now I may not understand some more details about STT though. I would love to hear some more details if there is.
Thank you very much. Any
Thank
other
you.
question related to speech to text or automatic speech recognition? We will be happy to discuss more.
Um,
There is another question.
with TRL and CRL, please. Uh, I'm sorry. Could you explain the abbreviations you're using, the acronyms you're using? Oh, okay, okay.
Mr. Hossein Muahidi, some more
Yes.
details, please.
Honestly, for reinforcement learning, what kind of algorithms do you use? Like, do you do like the basics, the min max and such?
Collective reinforcement learning.
Okay. What is okay? What is the issue that you're facing? Like your accuracy is not good?
Mr. Muahidi, when you are working with these tools, DRL and CRL, with framework.
Oh, honestly, I did not work with. The only time I had any contact with reinforcement learning, we really did the some algorithms from scratch. So I wouldn't be able to recommend a framework. I guess the basics. R has some algorithms, MATLAB as well, Julia, I guess, but that's about it. Oh, I see. There is, yes. Wait, scan. I don't. There is. I wouldn't know. I wouldn't tell you it is good because I only used deep neural networks with these libraries. But there is Keras. Yeah, there's Keras that they have deep reinforcement learning, and I heard of another one, I think, but I don't remember. But yeah, Keras is pretty well documented, I think, if you want to use that. But I don't know if you have already. But yeah, that's pretty much it.
Yeah. Any other question, please? Thanks. Okay.
I have a question for you. Did you think about doing end-to-end tasks? Like, do you do automatic speech recognition on Persian just to have the text, or is it for them some other let's say translation, for instance?
Yeah, we worked with text only, classification, summarization, and these stuff.
Okay.
Yeah.
And there was no way of doing it like end to end?
We didn't try it actually. We just used some specific algorithms like BERT, like distal BERT, like transfer stuff. So this one and this is all that we worked with Persian.
Yes.
Um, I think there is no any other question. If there is a question, we still have some minutes. So if there is no any other question, we will finish this presentation here. Thank you, Ms. Reem. Thank you for the nice presentation. There is no any other question from the participants? Yeah, please. Farzana. Farzana raised her hand and...
Oh, no, sorry. It wasn't. It was just a miss.
Okay, no problem. No problem. Again, okay, no problem. Thank you very much, Ms. Amrit. We hope that we have presentations in the future regarding the text, speech, or something related to NLP and deep learning AI stuff. So Hossein Mouahidi, have you any question?
Hello, teacher.
Yeah, please.
So I have one question. Now I'm working on with DRL and CRL in edge computing with digital twin. It's kind of cloud computing. Can you share your contact about you say another team work on in a network fields? Okay, can you contact or emails or phones? I know more about.
I'm so sorry, I missed it. Could
Uh,
you repeat?
he's asking if he faced any other problems in the future, maybe directly he can connect with you. So
Yeah.
if there is any possibility that you share email or any
Yes,
other.
absolutely.
Yeah.
My LinkedIn is Reem Amarat. So I think you can find me on LinkedIn. However, I would like to precise. I'm so sorry. I'd like to say that I am only a master's graduate, and but I may be able to direct you to some of my professors and my supervisors who would be a lot more knowledgeable. So yes, that would be nice. You can add me on LinkedIn.
Yeah, thank you very much, Ms. Mr. Mouahidi. You can ask Ms. Amarat in LinkedIn. So if you face any difficulty, she will direct you with some professors in LIA Avenue University, which is a university focusing for AI and especially in NLP, natural language processing. I think there is no any other question. Thank you very much for your time, Ms. Amaret. We are
Thank
appreciating
you, everyone.
your kindness and your support.
Thank you. Have a good day.
Same for you. Have a good day.